make sure that I've covered it all. So I wanted to talk about how do you find percentiles. We did not talk about that, right? Let's say that I have a bunch of data. Let's say I have 10 data points. I need blue. Let's say I have 10 data points. And the first thing I want to do is find the median. So we said once before that the median was robust. You remember that? Right? The median is robust. That means it's not easily altered by outliers. And I want to find the median of these 10 data points. So how do I go about doing it? You have a bunch of rules on page 28 in your notes. It says simply take n times p over 100, where p is the percentile that you are looking for. So I know that my median is P50, the 50th percentile, right? It's also Q2, the second quartile. Just think in quarters. Two 25s would bring me to 50, right? So it's the second quartile, and it's the 5th decile. So in any case, it's the 50th percentile, so this 50 is what goes in here, into this formula. Take n times p over 100, so this is equal to n times 50 over 100. Obviously, this is a half, so 10 times 1/2 gives me 5. Because 5 is an integer, you are to take the 5th and the next one, which is the 6th, ordered values, and average them. Average of the 5th and 6th ordered values, which makes sense because if you have 10 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there is no one middle. Wouldn't you have to take the average of this one and this one, whatever they are in order? So maybe this one is a 100, and maybe this one is a 200, and so your median would be 100 plus 200 divided by 2, which is 150. Follow? Yes or no? It's just a middle value. If I have 10 points, there's no middle. I have to take the average of this guy and this guy. That's what I've done. So what if I wanted the second decile? I want D2, which is P20. Deciles divide your data into tenths. So the second decile would bring you to the 20th percentile, right? The 7th decile would bring you to the 70th percentile, like that. So D2 is P20. So I'm going to say n times 20 over 100, which is 10 times 0.2, which is 2. Again, it's an integer. So take the average of the second and third ordered values. Mind you, this data is in order already. So I'm going to take this guy and find the average. And that would be the second decile. Now let's say it said find the 35th percentile. Then you would go n times 35 over 100. And if I wanted the first quartile, first quarter, that would be P25. I would say 10 times 25 over 100, which is 10 over 4, which is 2.5, which is a non-integer. When you hit a non-integer, the rule changes. You simply round up to the next integer, which is 3. So P25 is the third ordered value. Yes. Then you would round to 3. You always round up to the next integer. Yeah. So these rules are on page 28. It says here when it's an integer, you take averages. When it's a non-integer, you round up to the next integer and pick up that ordered value. Follow me? And the rule, that's on 28. And then a couple of examples, which we should do right now on 29. Let's do them. Page 29. It says, the cost of 27 different pain relievers in cents is given to you. Find the median. Okay, so I have 27 data points. N equals 27. I want Q2. And then it says, find the first quartile. That's Q1. I want Q1. And then it says find the third quartile, so that's Q3. And then lastly, find the interquartile range. That's Q3 minus Q1. Q3 minus Q1. So Q2 is P50, second quartile. So 27 times 50 over 100, which is 13.5, because this is just 1/2. It's a non-integer, so round up to the next integer. So the 14th ordered value. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I see a 50. 50. Follow? Yes or no? Don't use your calculator for this. The answer may not match up because the calculator may be using some different algorithm to find the percentiles, and it might differ. Don't use the calculator for this. Next one, Q1, P25. 27 times 25 over 100, 1/4. So 27 over 4, 4 6 are 24, and 3/4. Non-integer, right? Round up to the 7th ordered value. Who is the 7th ordered value? 1, 2, 3, 4, 5, 6, 7. 33. I'm going through the motion of doing this because I want to draw a box plot after this. Okay, that's why I'm bothering to do this. Q3. Q3, I don't really have to find Q3 because I've found Q1, and because Q1 is the 7th one from this end of the data set, Q3 will be the 7th one from the back end of the data set. So I don't have to start from scratch. I don't have to do this. Don't bother doing this. You don't have to. You're wasting your time because this is 81 over 4 and this is 20 1/4. And you're going to round up to the 21st value, which is the 7th from the end. Right? So what's the 7th one from the end? 1, 2, 3, 4, 5, 6, 7. It's a 100. 7th one from the end. Or you could count 21 spaces from the left end. That's up to you. So now I have my Q1, Q2, Q3, And I have my min and my max, which is the 5-number summary of this data. So there's something called the 5-number summary, which is min, max, Q1, Q2, Q3. I need this to draw my box plot. So my min is 16. I'm just looking at my data here and saying the minimum value is 16. So I pick that up. The maximum value is 123. So I pick that up. And my Q1 was 33. My Q2 was 50. And my Q3 was, I don't know if I figured that out, did I? 100. 100. So now I can draw a box plot given these values right here. So let's draw a number line. It has to be drawn to scale. So I need to go from 15 to 123. So let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So please make a vertical line at Q1, Q2, and Q3 each. So Q1 is at 33. We make a vertical line. At Q2 at 50, I make another vertical line. At Q3 is 100, I make another vertical line. And I connect this to form the box from the box and whisker plot. And then I connect the minimum to Q1. So 16 is the min, and I connect that to Q1. And I connect Q3 to the max, which is 123. Here's my box and whisker plot. This is 16, this is 33, this is 50, this is 100, and this is 123. So the interquartile range is Q3 minus Q1, which is 100 minus 33, which is 67. And that gives me the spread of the middle 50% of the data set. Meaning this spread right here is the IQR from here to here. This is exactly 50% of the data, because this is the 25th percentile and this is the 75th percentile. So between that lies exactly 50% of the data set. The longer the distance, the longer the IQR, the higher the variability of your data. Are you with me, or may I answer some questions for you? So this is one box plot, right? You can have many box plots right next to one another so you can compare many distributions. And I believe you see that on some of the following pages. I'll go there in a minute. Do you have any questions regarding this? This is just a regular box plot. Let's talk about modified box plots. And after that, I'll compare box plots. I kind of have to talk about modified box plots because the ones that I'm about to show you are modified. I'll show you what I mean by that. Look at these. You see these? These are parallel box plots, right? But they're all modified because these points here are outliers. So I can't talk about this until I teach you about the modified box plot. So let me do that. Let's say that I should also tell you where this lies in your notes. So let me see where it is in your class notes. It's on page 3. This page that looks like that. The packet that begins with this page, and this is what page 3 looks like. I'll reproduce it here, so if you don't have it, it's not a big deal. Let's say that you're given the following information. Q1 equals 10, Q2 equals 20, Q3 equals 50, and they gave you the data 2, 3, a bunch of data here, 88, 93, 109, 120, and 130 is the max. This is all given to you, the whole data set. And your job is to create a modified box plot. So you go to your number line. I have to accommodate between 0 and 130, right? So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So I start out drawing the 3 vertical lines at 10, 20, and 50, just like I did before. So at 10, at 20, and 50. Here's my Q1, Q2, Q3, so it forms the box of the box plot. And then it's different. Then it's different from the regular box plot. In a normal box plot, in a regular old-fashioned box plot, I would just go to the max on the right and the min on the left, but not for a modified box plot. For a modified box plot, I have to identify where the upper fence is. So first thing I will do is find the interquartile range, which is Q3 minus Q1. So in my case, it's 50 minus 10, which is 40. Take 1.5 interquartile ranges. That's 1.5 times 40, which is 60. So a distance of 60 to the right of 50, which is my Q3, would show me where the upper fence is. So Q3 plus 1.5 IQR gives me 50 plus 60, which is 110. So at 110 is my upper fence, right here. And my lower fence is Q1 minus 1.5 IQR. That's the lower fence. So Q1 is 10 minus 60. So that's negative 50, somewhere out here on the left side. I don't have any data to the left of minus 50, so I don't care about my lower fence right now. So here's the upper fence of 110. Any data that is larger than 110 is considered an outlier. So any data that's more than 1.5 interquartile ranges to the right of Q3 and more than 1.5 interquartile ranges to the left of Q1 would be considered an outlier. So on the right, I have 2 outliers, 120 and 130. Those are both outliers. So let's show them by asterisks. And then the 109, which lies inside the fence, is the maximum value within the fence. That's where the whisker would end. So let me label that as 109. And this is 120. It's not going to be labeled in the case of the output from your software package. It's just going to show 2 asterisks. That means there are 2 outliers. And then the whisker would extend to 109 and stop. So it extends to the maximum value within the fence. On the left side, I have no such thing going on because my minimum value is 2, and the whisker would go to 2 because the fence is somewhere all the way out here somewhere at minus 50. And there is no data value on the left side. But if I had a data value minus 60, that would be 1 asterisk on the other side of the left fence. Follow me? So this is a modified box plot. And then you can talk about parallel modified box plots, meaning lots of different distributions. So this tells me the variability in my data. I would compare the length of the boxes of the box plots. So variability given by IQR. So the more variable, the higher the IQR. I can also tell the skewness of my data set by looking at what lies in the box. So let me give you a box. Any idea of the skewness of this? Left skewed, right skewed, symmetric, what? How many say right skewed? How many say left skewed? And how many say symmetric? Look, people, you cannot look at the whisker to determine the skewness because the whisker will go to the last outlier, right? If this is a box plot, it's not a modified box plot. It's just a box plot, right? This value is the maximum value in the data set. This value is the minimum value in the data set. Let's say that this guy is an outlier. This maximum is an outlier. You cannot look at this whisker to decide the skewness of the whole data set just because there's one outlier. I'm saying suppose this guy is an outlier. That would make the whisker go crazy, right? But that doesn't determine the skewness of the whole data set. So you cannot look at the length of the whisker to determine the skewness. You are only to look at the box because that represents the middle 50% of the data set and will give you an excellent idea of the skewness. This will mislead you. Follow me? So you will look inside the box only. Now, this distance holds what percent of the data? This distance right here. How much data lies within that range? What percentile is this guy? Work with me, people. Q2. So what percentile? 50th percentile. What percentile is this one? 75th, right. So between here and here lies what percent of the data set? 25% of the data set. And I have a very small little range to hold 25% of the data set. So wouldn't it stand to reason that the curve is very high here because there's just a short little piece where 25% has to fall, right? So it's going to be stacked up high here. Here I have a much longer distance to hold the same percent of the data, because this is P25. So I still have 25% of the data set, but a whole lot of room for it. So the way the curve is going to be, I have a big distance to hold that, so the height of the curve will be less. So just look at it. Does it not look left skewed? Left skew. So you may only look inside the box, not at the whisker, to determine the skewness. On the other hand, if it looked like this, that would be, you can just connect the dots, right skewed. Skewed right or positively skewed. This one is left skewed, negatively skewed. And then here's the kicker. If your box plot looks symmetric, then no conclusion can be drawn about the symmetry of the data, because I can show you the same box plot that comes from a symmetric data set and an asymmetric data set, and the box plot will still be symmetric. So if you see a symmetric box plot, draw no conclusions about the symmetry of the data. But if your data is symmetric, your box plot will always be symmetric. So that stuff is on page 31. On the top of page 31. Both the distributions have the same 5-number summary and the same symmetric box plot. This one is asymmetric and this one is symmetric. It's just trying to make a point that when you see a symmetric box plot, it doesn't mean that the data was necessarily symmetric. So here I have 3 parallel box plots. It says, we see that the medians are roughly the same. So here's the median. Same median on all 3. The IQR, the interquartile range, is decreasing from one time period to the next. I can see that because this distance is getting smaller and smaller, indicating reduced variability of payoffs in the second and third periods. In addition, the extreme values are closer to the median in the later time periods. So it's saying that the outliers are closer in. Obviously, because the IQR went down, right? So 1.5 IQR will also go down. So the fence will be closer in. You get an idea of what this is saying? Let's look at the next page. So it's saying the box plot indicates the center of the distribution as well as the variability of the distribution, obviously. Here's the center, here's the Q2s. They're both just as variable, it looks like. This one's more variable than that. How about the skewness? This data is skewed what? Left or right? When you're looking at the box plot, right, you better turn the axis so that the lower numbers are here and the larger numbers are here, and then look at the skewness. So this would be right skewed or positively skewed. And how about this next one on page 33? So they gave you a box. You better make sure that the axis is turned properly. such that it goes from 0 and up on the right. And then look at the skewness. It's skewed left, negatively skewed. And then the last picture on page 33 says, which of the parallel box plots indicate distributions that have similar centers? That would be A and B, because we're looking at Q2. Which distribution has the largest standard deviation? That would be B, because the variability is the largest. Which distribution is right skewed? That would be D. This one is right skewed. Are you with me? Yes or no? Okay, questions? Righty. Let's see now. So 33, 34. What's going on here? Can we do page 34 and get it out of the way? You know everything on 34 already. Let's just do it. Draw a box and whisker plot for the following 15 data points. First, we order the data. So I see that the data is jumbled, right? Let's order it. Stem and leaf. So 0, 1, and 2. Let's get the leaves done. So 1, 0, 1, 3, 1, 1, 07, 09, 05, 1, 6, 1, 7, 1, 5, 1, 4, 3, 7, 2, 0, 2, 1, 1, 8, and 1, 9. I'll make another pass through the data, ordering the leaves. So 0, 5, 7, and 9. I'm ordering the leaves now. 1, 0, 1, 3, 4, 5, 6, 7, 8, 9. And 2, 0, 1, and 3, 7. I think I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 15. Okay, so it says compute the quartiles and draw the box plot. Let's go. Can we do this in like 2 minutes? Compute the quartiles. So Q1 is P25. So 15 times 25 over 100, which is 15 over 4, which is 4 3s are 12 and 3/4. It's a non-integer. Round up to the 4th ordered value, which is 10. Q2 is P50, 15 times a half, which is 7.5. Non-integer, round up to the 8th ordered value, which is 1, 2, 3, 4, 5, 6, 7, 8, 15. Q3 is the 4th from the end, because Q1 was the 4th from the front. So 1, 2, look how I'm going backwards. 1, 2, 3, 4, 19. So I have Q1 is 10, Q2 is 15, Q3 is 19, outliers are defined as values that lie more than 1.5 IQRs to the right of the upper quartile, or more than 1.5 IQRs to the left of the lower quartile. So I guess they want a modified box plot, right? Because they're talking about outliers. So let me find the interquartile range. That would be Q3 minus Q1, which is 9. And 1.5 times 9 13.5. 13.5. So 13.5 to the right of 19. So the upper fence is 19 plus 13.5, 22.5. No, 32.5. 32.5. Anything more than 32.5 would be an outlier. So 37 would be an outlier. This thing is 32.5. And on the left side, lower, would be 10 minus 13.5. So minus 3.5. So that would be somewhere here. And there's nothing on that side. So the minimum value is 0.7. And the maximum within the fence is 21. So here is the modified box plot for this picture. Does that make sense to you? Okay.